All right, if you are watching this video, there is a 90% chance that you just jumped straight to this video and you skipped past the previous videos that talked all about networking protocols because you saw the name of this video and you thought, oh, I want to figure out how to configure my switch, which is a good thing, but you really should go back and learn why you want to configure your switch that way. I get it. Don't get me wrong, I understand you don't want to listen to me talk about networking protocols for hours on end. You're not the only person in the world. That is the main reason why I am single. That and the fact that I am the owner of a face that just screams Harry Potter's nerdier cousin. But unlike my exes, you're stuck with me. So sit down, we're gonna talk about networking requirements, what we have to do to make sure that our switches can properly send audio, video, and control traffic across our network. So let's start off by talking about bandwidth. Our networking switches should include non-blocking wire speed gigabit Ethernet. Well, what on earth does that mean? That means that the backbone of the switch has to be able to carry concurrently the full capacity of all of your traffic. If the backbone of your switches were flooded with traffic that you cannot handle, that is going to severely limit the PTP clocking delivery. That's going to introduce jitter. That's going to bring down the whole system. In this situation, here we have 10 video encoders, 10 different video encoders that are going through a gigabit switch, delivered to another switch with 10 decoders. It's possible that all 10 of those encoders will have a one-to-one connection with the decoders on the other end, which means that the backbone between these two switches needs to be able to handle the entirety of that traffic between them. So when you are trying to figure out, as the topology of your switches go higher and higher up, the connection requirement between them, this is what you think about. Keeping in mind, video streams could be up to 800 megabits per second. That is a lot of traffic that could be funneling through these switches as your switch topology has more and more devices that require those switches to connect to each other. So keep that in mind. Where all your traffic is coming from, where is it going to, that will determine what level your switch needs to do. It may be more than a gigabit. It may be a 10 gigabit switch, maybe a 40 gigabit switch, maybe a 100 gigabit switch, depending on the needs of your system. And a really important thing to start talking about is QoS, quality of service. Quality of service is a protocol that categorizes and prioritizes networking traffic so that time-critical information, such as clocking, is delivered at the appropriate times, and that other lower priority packets are delivered according to their protocol needs. This allows QLAN to operate on a shared network without segregating audio traffic from other data traffic. Think about it like this. We've already talked about all kinds of different types of traffic that will be coming through the switch. Well, some of that is more important than others. If a high priority packet comes in at the same time as a low priority packet, your switch needs to be able to figure out which of those packets is important and send that one out first and then deliver the other ones. We've got those clocking packets that have to keep on coming out at a specific pace, right? We don't want a video packets to be clogging up like a traffic jam and preventing our clocking packet from going out. So we need a way to determine which of these packets are important and which of them are less important. We won't call them not important. It's all important. We get it. You want your package no matter what. It's not that it's a useless packet. It's that other packets are more important. So how do we do that? We apply quality of service. Quality of service is a way to make sure that larger communications do not disrupt the delivery of your real-time audio and video and control by blocking those clocking packets from going out at the speed that they should. Because if you get this wrong, then QoS is going to start standing for quantity of swear words. And not just the swear words that you are saying, but the number of swear words being thrown at you by the other people in the system. And you want that QoS to be 0. So in order for that to happen, you got to make sure that this QoS is configured properly. Well, how do you do that? Well, QoS is basically a packet that is applied to all other data. What we have here is a Wireshark capture of all of the traffic that's going in and out of the core for this particular device. And you can see that there's something called DSCP, Differential Service Code Points. That is an assignment of importance. It's a class. It's some level of priority. And it may be represented in different ways. It may be represented in hex. It may be represented in decimal. Here we have these class assignments. But you can see that every single packet has been assigned some level of importance to it. and we need to make sure that we are doing that appropriately. Now, your switches must be able to support at least 2 classes of DSCP classification, and essentially there are 64 possible priorities between 0 and 63 that could be assigned to them. Now, this prioritization assignment is frustratingly arbitrary because there is no internet rule on what an important packet's number should be versus what a less important packet's number should be. For instance, we assign our clocking packets, which is really important, at number 46. Whereas another manufacturer may set their clocking packets, which is also very important, to 56. Well, now we're going to get into a problem where their clocking packets will be delivered before ours, and what if ours is now sent out at the same speed as their audio packets? That's what we're going to see on the next slide. There's no way to get everyone to agree on the same convention here because it's just not going to happen. It's like if we tried to get the United States to use the metric system. It's not going to happen. I don't know why. I don't know why it's not going to happen. It should happen. It would make sense for everyone in the world if we just got on board and used the metric system. But here, everyone is right. So instead of forcing everyone to play together, we're going to adapt the properties of our design so that we can play nicely together. And that's what we're going to see right here, over here. So we've got our clocking packets at 46, DSCP of 46. That's our clock. Whereas Dante, for instance, uses 56 as their clocking packets. All right, well, the next category down is audio. We set our audio priority level at 34, which is our second most important priority, and they set theirs at 46. You can see already their audio packets, which are significantly larger than a clocking packet will be, now is in a situation where it's being delivered at the exact same time as our clocking packets. Now, this isn't always going to be a problem, but if there's a lot of Dante traffic on the network, you may certainly come into a circumstance where our clocking is now being delayed because so much of their audio is being delivered in the same priority queue. That's why this is really important. Anytime you've got Dante on the network, this is usually something that will come up. Down the line, video is the third most important priority queue. We have 26 as the DSCP value for our video, and Dante, for instance, assigns that to 26 as well. There we are harmonious and line up. And generally speaking, everything else like control is considered best effort, where it'll be in a lower queue and it will go out when it goes out. You know, there's no deficits for a Q-SYS discovery protocol packets to being a little bit delayed, right? It doesn't hurt us that it takes a couple microseconds longer for the touchscreen device to identify itself. But clocking is really important. We've got to make sure the Q-SYS is configured so that the clocking always comes out. And in most switches, this is going to be configured via a strict priority hierarchy, where the switch will essentially have several queues, and you assign what priority level is set into each of those queues. We need to make sure, for instance, for us, that the clock value is put to the highest queue, and the audio packets are set to the second highest queue, and the video packets to the third highest queue, and sort everything down to the fourth one. Some switches only have a 4-class model like this, where there's only 4 queues. If you've got an 8-class model where there are more queues, we still need to make sure that clocking and audio and video are in the top 3, and then everything else can be relegated down in the lower queues. Here's a 12-class model, same idea. Everything, strict priority, number 1, number 2, number 3, you have to tell it what number goes into number 1 and number 2 and number 3. Okay, but we just said that what number is it could vary, right? Well, there is a place in the software where you can go to change that. If you go up to the properties and you select design properties, here we have QoS preset options. And by default, this is set to QLAN, which are the numbers that we just mentioned. But you can change it between QLAN, Audinate, or Manual. And if you are in QLAN mode, then it will show you right there that your clocking packets are 46, audio is 34, camera is 26. If you change this to Audinate, that will automatically just change our packets. It's as simple as that. We just say, hey, you know what? Let's take our clocking packets and now send them out at 56 as well. And we'll elevate our audio packets to 46. That way we have the same priority levels as what Audinate is doing, and everything's going to be treated very nicely. There's really no harm in applying this to every one of your designs. It doesn't hurt anything to change these levels. This is just one of the methods that we chose when we built ours. They chose their way when they built theirs, and we can do this to make sure that they are all working properly. Pretty rarely would you ever want to go into manual mode. If you're touching manual mode and you're assigning these yourselves, you better know what you're doing. That's going to be for rarer circumstances that probably aren't the situation if you're watching this video right now. Let's be frank. So these are your options on how to reconfigure your Q-SYS presets, and they're in the design properties. You should be using these. Now, these are things that you're going to need to configure at the switch level, right? And every single switch manufacturer has a different GUI that you will go to, and you'll have to find where these settings are in different ways and figure out how they are naming them. So this could be a pain point if you have to go in and figure out yourself. One of the reasons why you may want to consider using the Q-SYS network switches, which we offer. We'll talk about that in a little bit. Takes that pain off of your shoulders. But once again, if you do need to configure these yourselves, you can also go to the help file. It'll go through all of these with you and remind you what these DSCP values are for the different priority levels. So do be aware of this. Managing QoS is a very common thing that people don't get right the first time. All right, next let's talk about IGMP snooping, which sounds like a Hulu exclusive buddy spy comedy, but in reality, it's the way that you make sure that your video streams don't end up on your break room coffee maker. So we showed you this slide earlier about multicast, where if you've got a sending device that wants to send information to multiple recipients, it sends it to the multicast address of your switch, and then the switch delivers it to multiple places. That's generally fine, unless the thing that it's sending is going to be a video stream. And if you're sending video streams, that could be problematic. Because what if you're sending that video stream to a lot of devices that don't want it? I don't want to send my video stream to my laptop. It's not configured to receive it. I only want to send it to my video decoder over here. What about a touchscreen panel? That shouldn't be receiving your video streams, but you know what? If multicast is not configured properly and IGMP snooping is not configured properly, you may inadvertently be sending video streams to your touch panel. It's kind of the reason why we're doing all of this. You wouldn't think that a touch panel that's acting kind of glitchy would be caused by video streams on your network. But the reality is it may be so sluggish because somewhere else on your network you haven't configured your multicast properly. So, how do we make sure that we only send important video stream multicast to the devices that want it? That's where IGMP snooping comes in. So IGMP, which stands for Internet Group Management Protocol, is what we use for Q-SYS devices to subscribe to the content that they are interested in, right? They may want the video streams that we just talked about, but it's also important for things like the QDP and things like the clock synchronization protocol. They are electing to receive this type of multicast traffic. Without IGMP, then all multicast traffic essentially is broadcast traffic, which we talked about how we don't want that. So we're going to use IGMP snooping to make sure that the querier on the network asks every device which multicast traffic they want. It's going to send out and say, hey, when you come online, you tell me what kind of multicast you want. And it'll keep on asking periodically throughout the course of the network, hey, remind me, do you still want this traffic? Do you still want this traffic? Whenever I get that multicast traffic, I'm going to deliver it to these devices. You can see that without this, if we put another sending device on the network, we have another 800 megabit per second video stream coming in. Again, we're already flooding all of these devices with just way too much traffic that they did not want. That's when we don't have the querier. This querier is the switch that manages the delivery of things. The querier listens to the devices. The device says, hey, I'm subscribing, in this case, to stream B, and then we only send the second video stream to that device rather than the first one as well. That's how we make sure that these receiving devices don't get flooded with too much traffic. Meanwhile, our laptop and our touchscreen have clearly never answered a query about multicast because that is not part of their protocols at all, so we're not sending any of that multicast to them. So the key here is that you do have to have IGMP snooping enabled on all of the switches on the network, but only one querier. There should only be one switch that is configured as the querier itself. That is the querier that is listening and asking and distributing all of that multicast information. It is also recommended, if you're using video streams, You may want to consider enabling IGMP fast leave as an option on your switch. Fast leave essentially will make sure that the previous multicast stream stops before the next one begins. And if you are doing video routing and you're swapping from source A to source B, you wouldn't want there to be that momentary couple of packets where we are still sending stream A while starting to send stream B, because that's going to be, all of a sudden you're doubling the bandwidth for those couple of microseconds. You don't want that. Also, really worth noting that IGMP snooping often is not going to be able to transmit past your VLAN. So if you are doing IGMP snooping and multicast traffic beyond your routers, beyond your VLANs, you will probably need to engage PIM sparse mode. That's protocol independent multicast sparse mode, which is the only way to get that multicast traffic outside of your immediate region. It's probably a good idea for the core to be connected to that querier switch. Now again, having only one querier on the network is critical. Some switches, like ours, manage themselves automatically and will make sure that there is only one querier active. But if you are managing your switches manually, do be sure to go through all of those admin settings. Make sure that only one is the querier, while all of them do still have IGMP snooping enabled. Determining the number of switch hops in your network is also very, very important. Generally speaking, we recommend 3 switch hops between Q-SYS devices. Here we have our layer of Q-SYS devices on the bottom. They will all be then connected to an access switch. Those access switches are then connected to each other via a core switch, and the core would be connected to that. You can see for that, then we have only 2 switch hops to get from the Q-SYS devices to the core, but keep in mind that you do have things like video devices that are not going to the core itself. So this would be a 3-hop network to go from maybe a network device here that is sending its video 1, 2, 3, and to another video output elsewhere. 3 hops is ideal in this case, but for larger systems, you will see that this tier starts to grow. So here we have a 25 gigabit backbone between our 2 cores, but we are still maintaining that topology of having our Q-SYS devices on one layer, our access switches on the next one, and they are connected to each other one layer up. As your system gets even larger than that, here we have a layer of distribution switches, but we've still been very smart about where we place our core in this system, so the core is connected onto a switch as part of that distribution switch network. Here we have a 40 gigabit backbone connecting that together, which means that we still have a maximum of 3 hops from the devices to the cores, and you'll notice a maximum of 5 hops from a video endpoint to another video endpoint. So those are your switch hops. I know I've said a lot of things now. Let's see if we can summarize some of them. Let's see if we can give you some fast and furious, really good, like best practices, do's and don'ts of what we want to do. General recommendations. Number 1, Wi-Fi. Wi-Fi is for users, not for devices. Wi-Fi is great if you're going to connect your iPad or your iPhone to the system and you want to control it, but do not ever use Q-SYS as your network over Wi-Fi. Just a bad idea. Next up, enable LLDP, Link Layer Discovery Protocol. Link Layer Discovery Protocol is a way for Q-SYS devices to not only share their identity, but also their location on the network. That could be very important for a couple of different applications, so that is something that we generally recommend is enabled. We do recommend that, if possible, you consider separating your Q-SYS network from other network traffic. If you are able to use VLANs to make sure your Q-SYS is essentially living in its own silo, that could be a good idea. It generally helps you to control your own environment without interacting with other environments. It does also introduce a layer of complexity when you are trying to control things that are on those other networks. So if you have segregated QLAN from your Dante, well, now you've got to be able to make sure that your control is able to cross from QLAN to Dante. But whenever possible, consider if you can isolate your networks. It might be a good idea. Also, you may just want to consider culinary school. If none of this is really making sense for you, this is always a solid option. It's never too late to just give up and do what your heart tells you to do. Cooking is important. It's probably, I'm guessing, easier than setting up your switches. Other things to consider is disabling jumbo frames. A lot of switches allow jumbo frames, which is essentially a size allowance of packets that would be extraordinarily large and would overwhelm our ability to send out our clocking synchronization packets. So if your switches can disable jumbo frames, that's a good idea. That prevents some giant major print job from clearing out all of the audio coming down on the system. We do generally recommend to disable spanning tree protocol, STP, on any ports that have Q-SYS devices on them. STP is a way for switches to sort of reroute themselves based on the easiest path between two connections, whereas we would prefer that our Q-SYS devices determine that ourselves. So disabling STP wherever there are ports that your Q-SYS devices are connected. Also disabling bandwidth throttling, also known as traffic shaping on ports with Q-SYS devices. Again, we want to make sure that our devices are in control. We don't want the switch to determine how much bandwidth is allowable for each port. So if you have this property on your switches, that's another thing you probably want to disable. Here's something interesting, IEEE 802.3az. This is generally like an eco-sharing protocol, which you'd think would be a great idea. This is a way of turning off the PoE on devices when they're not being used. Sounds like a great idea. We're all for saving the environment, but our devices, we prefer that they manage their own power. If you've got a network encoder and it hasn't been used in a little bit, we will allow our encoder to manage its power rather than the switch to decide when to yank its power out. Disabling that protocol could be important, especially if you've got video devices on the network. And also, no optical network media converters. If you've got a third-party media converter that converts twisted pair to fiber, generally speaking, those can add latency and jitter. So we recommend instead just using a first-party SFP insert, so the fiber goes directly from switch to switch. So those are some good 10 easy do's and don'ts. Keep those in mind. We'll take a break right here, and in the next section, we'll just dig in deeper. See you in a bit.